what are we doing? We are going to be counting on the abacus. We have 1. We have 1. And then when we look, we have 2. What are we doing? This is an abacus. This is a counting tool. Boom. All right. And this is my workbook. This workbook is available. Oh yeah, this book is available. And when we look, we're going to be talking about 1. When we have 1, 0. This is 0. So what we're doing is this is 0. None of the beads are touching this horizontal bar, so this is what we call 0. And then we have 1. 1 bead touching the bar, right? So when I look, I have this, there we go. I have this pig. I have this 1 pig. This 1 pig, that's what 1 looks like on the abacus, right? So if 1 pig, 1 on the abacus. Oh, I wonder if I could do this. There we go. Ooh, even better. All right. So then we have 2. We have 2 snakes. So if you look on the abacus, we have 2 on the abacus. That's what 2 looks like. Okay, how are we doing? Anybody have any questions? Welcome, everybody, welcome. So what we're doing is we're talking about the abacus. This is my abacus, and it counts and helps me understand how to read. What we're doing is we're understanding how to read the abacus. So we have 2, and then we have 3. We have 3 chipmunks, so on the abacus, we have 3 on the abacus. And what are we looking at? We're looking at this right here. That's what 3 is. So if we look at the abacus, it would be 3, 3, 3, 3, 3, 3. These are all 3s. And then we have 4. Okay, so 4, like 1, 2, 3, 4 koalas, those are 4. 1, 4, 4, 4, 4, 4, 4. So that's what 4 looks like, right? All the beads, 1, 2, 3, 4, all these beads, 1, 2, 3, 4, because they're touching the horizontal bar, it is considered 4, right? So what we're doing is we're understanding how to read the abacus. Well, what's 5? Well, when we go through, see, this is just my book. This is my book for abacus, and we're just going through and understanding how to do 5. 5 is always going to be the top bead. 5. This is what 5 looks like. 5. 5 horses, all of this together, that's all 5. Okay? Anybody have any questions? Well, then what's 6? Well, what's after 6? After 5 is 6. That's what 6 looks like. 6 is 1 bead on top, 1 bead on bottom. These are all 6s. So I have 6 sheep. I have 6 on the abacus. Does that make sense? So, yep. That's what 6 looks like. And then what's after 6 is 7. 7. 1, 2, 3, 4, 5, 6, 7 crocodiles. 7 on the abacus. And what we're doing is we're just learning to read the abacus. Thank you so much for the hearts. Thank you so much for the hearts. I appreciate that. Let me know if you have any questions because it doesn't seem like anybody else is here. All right, so 7. After 7, and then after 7, we have 8. We have 8 little bunnies, and then 8 on the abacus. So we have 8. 8, 8, 8, 8, 8, 8, 8. This is all 8s. And then we have 9. We have 9 cows. So 9 looks like that. 9, 9, 9, 9, 9, 9, 9. Well, now, what are we going to do when there's 10? Well, 10, funny, looks like this. 10 is this. That's what 10 looks like. Well, how do I know? Because now I have my 1s, my 10s, my 100s, my 1000s, and my 10,000. So when we're looking, every column on the abacus is a place value. Every place value has 9 digits, right? So when I look, 1, 2, 3, 4, no. This is 10, 20, 30, 40, 50, 60, 70, 80, 90. And we had the same thing here. 1, 2, 3, 4, 5, 6, 7, 8, 9. And then we have 10. Which would be the same thing if we did this. This would be 100. How do I know? Because every column is a place value. So we have hundreds, thousands, 10,000s. So when I review, I'm going to count 1, 2, 3, 4. That's what here. We're at the ones place, right? We could do it again. 10, 20, 30, 40. We could do it again. 100, 200, 300, 400, or 1,000, 2,000, 3,000, 4,000, or 40,000, no, 10,000, 20,000, 30,000, and 40,000. Is that right? Yeah, that's right. So then you might be wondering, well, what about here? Well, over here is where we talk about decimals. Because if you notice, we have our ones and we have our tens. Our ones are tenths, decimal sits. So we have our ones or tenths. So if we wanted to, this would be 0.4 or 0.44. Yeah? How are we doing? Anybody have any questions? Let me know. So in the chat, give me a number that's less than 99,999. So I could show you what it looks like on the abacus. In the chat, just give me a number and I'll put it up. Hey, thank you, Miles. Sleep. Okay, so we have 842. Let me write it out. So we have 842. Just so we could see it, right? So we have, 842. Remember that this is my ones, right? This is my tens, and then this is my hundreds, right? So when I look, I have 842. So I have 8, 5, 6, 7, 8, 4, 1, 2, 3, 4, and 2, 1, 2. And it's interesting because every place value, every column is a place value. So 1, 2, 3, 4, 5, 6, 7. So Ayo give me 7. 1, 2, 3, 4, 5, 6, 7. So I go here and I go here. Well, obviously that's a little bit too big. But what's going to happen? I just need to get a bigger abacus. So Ayo, this is my bigger abacus. And so when I look, I have 5000000. That's it. That's what it looks like. So that if I light it up, it would be like that. 500000000. Not very exciting, but that's what it is. And now the question is, well, what's the difference between the colors? The colors mean nothing. The colors just make it look pretty, right? What we're looking at is we're making sure that we have the positioning. So this was 5. And why do I have it here? Well, I chose this one as my ones indicator, right? If you notice, I have my ones indicator. I have multiple ones indicator. But you could just choose any one, just like a Pokemon.
Come on! I choose you!
So in this case, I chose this one to be my ones case, my ones indicator. Sometimes, usually on a 13-column abacus, I choose the one in the middle.
Okay, Charizard, I choose you!
So then when I'm looking at it, oh, hey, Julia, I used an abacus with tactile learns. With tactile learns? That's very interesting. Thank you for the follow. What kind of abacus did you use? Did you use a Soroban? And how long did you use it for? That's fantastic. I'm so happy. So, I don't know if Julia, I want one. I want one to now. Oh, if you want one, I have the 13-column one. If it's for you, I have a 13-column one. I would suggest the 13-column one for the adults just because you could do more numbers with it. Or if you want, you can have the colorful one. This one. This one is for smaller number. Well, this one is for smaller numbers, but you can use the same one. You can use the 13-column one for same numbers as well. It's just that you're able to expand on bigger numbers for here. More than 13, middle school. Oh, interesting. You did 13 years of abacus, Julia? That's fantastic. So you know how to add and you know how to multiply and divide? You should be able to know how to multiply and divide then. And where did you learn this, Julia? 13. Oh, I see. No more than 13. Oh, I see. Yo, give me the rundown how to use this. Hold on, Zaza. How long did you... Oh, for middle school. So do you know how to subtract, multiply and divide, Julia? That's pretty cool. And where? Where did you learn it? That's interesting. You have the 13-column one, which is good. 13, I think, is really good. I think it's very beneficial. But I like this one just because it's nice and pretty. And it's easier to see, right? It's easier to have fun on the when people are looking. So, Zaza, thank you for your comment. So we're going to do a little rundown. When we look, I remember finding a thing way algebra, but my algebra told me to use the way or fit. Oh, that's too bad. I learned it because I was interested in slide rules. And then you're one more than me. I don't know how to do slide rules. That's too bad, Zaza. It is too bad. But you know, the biggest thing is you need to show your work. And Abacus doesn't do really algebra, right? So it kind of brings it in, but that's too bad about your teacher. Okay. So and then the other question is what grade were you in, Zaza, when you found this? So here is 0. When we look at 0, 0 is this. This means that we have to look at the beads, right? Any of the beads, it was in 8th grade. Oh, yeah, in 8th grade? That's too bad. In 8th grade, yeah. So this is 0. None of the beads touch the horizontal bar. The horizontal bar is what tracks the beads. So when we're looking and we want to do 1, all it is just moving the beads. We have 1, 2, 3, 4. All the lower beads has a value of 4. So then the top bead is 5. Because the top bead is 5, then we can go into making 7. So how do we do 6? So we have 5, and then 6, 7, 8, 9. And then if you look, every column is a place value. So we have 10, right? 10, 11, 12, 13, 14. Abacus only helps you with adding, subtracting, multiplication, division. So I'm not sure a quick way to do algebra. I'm not sure why you would use an abacus to do algebra. Yes, Julia. It helps students to carry place. Yes, thank you. It helps students to carrying place values. Yes. Let me see if I can pin this comment. That's fantastic. Thank you so much. I think I got that. Okay. So what we're doing here, so then you can count, right? You can count higher. We have 10, 20, 30, 40. Now we're counting by tens, and then after we count by tens, we can count by hundreds, thousands, and 10,000. This specific abacus is only 7 columns, right? So when we're looking at this, right? So this is 0. So we know how to use the abacus, right? Okay, we're done using the abacus. No, we're not done. What we're going to do is we're going to continue on learning how to read the abacus. To do that, we are going to go through this maze. And I created this book to help us figure out what sort of place values we have. This one is only 2-digit. I'm working on 3 digits and 4 digits, but it takes a little bit of time to create workbooks. So they're easy to do. It's just doing them just takes time. All right, so here is a maze. It's more complex. It feels arithmetic. Oh, okay, cool. Oh, that's interesting. Okay, it helps. I'm sorry. With more complex algebra, it fills the end of the arithmetic. Yes, it does. And it's the gateway, right? Abacus is the gateway to more complex math. So here is my maze, and what we're going to do is we're going to go through each of the numbers, and as we go through the numbers, it's going to tell us which path we're going to go. So here, if I look at this number, I don't know if you can see that. Let me make it smaller. So here is my number. What number do we think this is? And this is my maze. So we have this number and that number. What number do you think that is? Oh, hey, Pause on Budget. Welcome back. Good morning. Yes, it is 15. All right, does everybody concur? So we have 15 and we go over here. After that, we go to here. Hello. All right, so we have this number. And if I look, we have this in our tens. And then we have this at our ones. Hey, Mohammed. Yes, thank you. Yes, it is 24 because we have 20, right, in our tens, 2, and then 4. 1, 2, 3, 4. Yes, 24. Thank you. So we're going to go to 24, and then here is, get my face out of the way. There we go. So we have this number. When we have this number, we have our tens and our ones. If I have my tens and then I have my ones, what number do we think that is? Oh, no, not 22. Hey, Laura! 72. Yes, 72 because it's 5, 6, 7. 35 can be done 5 times 5 times 5 on the. Okay, look, okay, Julia. Oh, okay. So we have 72. 72 takes me up to here. And then we have this number. What number do we think this is? So, Mohammed. It's okay. I mean, we all just understand what's going on, right? So we have we have our tens, and then we have our ones. So yes, we have 16. Thank you. Thank you, Mohammed. So we have 16, and we go all the way up to here. And then we have that. So when we look, we have our tens, which is this, and our ones, which is this. So what number do we think that is? 34. 1, 2, 3. 1, 2, 3, 4. Yep. 34. See? This is easy. This is too easy. Yes. Good. 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 So if I have tens, my tens, and then my ones, what number do we think that is? 88. Well done. Well done. So that would take me down to here. Oh. And I have that. Let me see if I can move it up a little bit. There we go. So that one is this. We're working on that right now. Hey, Cruppy. 79. So it's 79. 5, 6, 7, and 5, 6, 7, 8, 9. Almost, Cruppy. You forgot to take a look at the top bead. So if we had 24, it would actually look like this when there's none of the top beads added. So when we look, the top bead is always a value of 5. So when we're having it and we're counting, we want to make sure that any of the beads touching the horizontal bar now is being counted. So we have 5, 6, 7, and then 5, 6, 7, 8, 9. Yeah? 79. Okay, there we go. Yep. So, yeah, no, thank you for commenting. Thank you for participating. Because if you didn't participate, I wouldn't know where the information lies. So if I had this number, this would be the tens, and then this would be the ones. Don't forget, my ones has a 0. Thank you, Mohammed. My ones is a 0. So we have to remember to keep this as a place value, right? We need to have a 0. So this would be 50. Yes, so it'd be a 5 and a 0. And then it'll take me over to here, right? So this is a maze that I created, and what we're doing is we're just learning to read the abacus. When we're learning to read the abacus, then we will go into adding and subtracting, and then we'll do some adding and subtracting. We have our tens and our ones. Thank you, Mohammed. So we have our 30, 1, 2, 3, and our 7. 5, 6, 7. Good, good, good. And then we have this number down here. If I have my tens look like this, and my ones is like that. 27. Thank you. Mohammed's on fire. Okay, cool. This makes sense, right? So what we're doing... Hey, Pancho! So, sorry. So we have our tens. Our tens look like this. And then our ones look like this. And our answer is 87. 87. 5, 6, 7, 8. And then 5, 6, 7. Yes, thank you. And then we are at our finish line. What number do we think this is? We are just about done, and we can start adding and moving our numbers. So if I had, this is my tens and this is my ones, my final answer is, survey says, 59. Good job, Cruppy. Good job. Yes, 59. Easy? Easy. Easy. All right, cool. So that was my maze, and there's a bunch of them, right? But this is the cool one. I like this one. This is called a reverse maze. And what I did was I gave you the path, but you have to color in the abacus. So you start from here and you look at the number ahead. This is 54. So this is I called a reverse maze because I give you the path, but you need to fill in the abacus beads. So here is 96. So I have to color in 96. And then I go to this box over here, and then if I want it to color in this box, I just need to go to 29. So I have to color in 29. So this is what I call reverse maze, and there's a bunch. And in the reverse maze, in my maze book, I give you the answers. Can I order that book? Yeah, it's in my shop. I think I did it. Ah, huge. Have a good day. I learned. Okay, good, Cruppy, good. I have a good day to you too, Cruppy, and hope to see you next in my life. Yeah, I believe. Yeah, I pinned it. I pinned it. So if you look, it is there, available. It is available for yes. And so now what we're going to do is we're going to understand how to move the beads. So, what is this? This is an abacus, right? But what we want to do is we want to be gentle with our abacus. And if you notice, when I move the beads like this, I'm using the top of the edges of my beads, right? You're not going to see it because when you look at it like this, it's not, you can't see what I'm doing. But when you look, I'm actually doing this, right? I'm feeling the edges of the beads and I'm just using this. You don't want to be aggressive. Don't be aggressive when you're doing abacus. You want to be happy. Be happy when you use the abacus. And you want to make sure that if you have an answer, let's say we have an answer, and I flick, don't flick too hard.
And flick. Oh, you flick too hard, damn it!
Don't flick too hard because your answers will become incorrect. Why? Because the beads are very easy to move. They slide all over the place. They slide all over the place. So I don't know what soy bow is. It's an abacus. So it's A, B, A, C, that one. It's an abacus. So when we're looking, oh yeah, so don't flick too hard because your answers are going to, see, notice even I do this, my numbers are getting wrong. So you have to make sure that when you're looking at the abacus, it is very easy to move. Because it's easy to move, be gentle. And then when you look, oh my gosh, what's going on? There we go. There we go. Hey, user 397, welcome back. Don't flick too hard. Make sure you're happy when you use the abacus, right? We don't want to be angry. And also notice it's very easy to rattle. It's like a little rattle, right? So since it's easy to hold, you would need to hold it. When you hold the abacus, I usually hold it with my left hand. It's been recommended to hold with your left hand because you use your calculations with your right hand because you do calculations with your left hemisphere. So that's why you use your right hand to be able to do this. And this is not mirrored, right? You should be able to see this regularly. So if you notice, I use my right hand to do the calculations. I use my left hand. Some kids do two hands. That's 2-2. You could do that. I don't teach it this way, but kids do. I don't know if it helps or hinders, but I think as long as we could see the abacus in your mind, then I think it's helpful. Hello. I'm glad I caught the live. Oh yeah. I'm a little bit later than I normally is. But yeah, I'm so happy you're here. So we just talked about how to don't flick too hard, and we talked about anybody else any questions. So might be a question like, why are we over here and not over here or whatever, right? Well, if you notice, I have a ones indicator. This ones indicator I decide to choose. Oh, I talked about it already, right? So I'm choosing this Pokemon. I'm choosing this dot indicator where my ones is. That's why I'm over here.
Okay, Charizard, I choose you!
Right? So when I look at it, I can have my ones, my tens, my hundreds, my thousands, my 10,000. If I chose this one,
Pokemon, I choose you!
then I would have to shift everything over, and I have my ones, my tens, and then my hundreds are over here. User 397, do you have any questions for me? Before I continue on, because it seems like, and then Saya, did that answer your question? Is it for middle school? What's for middle school? You did abacus for middle school? That's really interesting. What school? Oh, Julia, what school? Like here in the States? That's fantastic. Oh, I wonder if Julia's still around. Saya, I don't know if you're still here. Okay, so, not yet, just setting up. Okay, so what we're going to do now is we're going to understand how to move the beads. What does that mean? Well, when we do abacus, right, what we want to do is we want to focus in on the add-in. What does that mean? Well, in mainstream school, mainstream math classes, right? In the younger grades, we always focus on the result. But in the abacus world, what we want to do is we want to focus it on the add-in. So when I have the 5, my question is add the 5, and then the question is, can I add the 1? Is there enough beads to add the 1?
Yes, we can.
So yes, we do. So all we got to do is move this bead up 1. When we're looking at it, I'm not looking how to make a 6. What I'm looking for is, what do I do to add the 1? All I need to do is move the 1 bead up. So then that's about adding 1. We can do the same thing with the 2. The 2 is the same thing. Because we have 6 and I want to add 2, is there enough beads to add the 2? Yes, there is. So all I got to do is move the 2 beads up. And that's all we're doing. So we have 3, and then if you notice, we have the 5, and then we have the 5, and then we want to add the 3. We just have the 3 beads. 1, 2, 3. You could go through mainstream math, and you could start doing what they do is like they have these dots, right? So you can color in 5 dots, and you could do three dots. You could, or you can do it through the abacus, and it does it for you. So I know that this is 5, and I'm going to add 3. 1, 2, 3, and I add the 3, just like that, right? And then 4, there's not too many questions with the number 4. And what we're doing is we're just working our way through this book. This book is what I have for preschoolers if you're looking for learning to introduce math to preschoolers. And when we look, we have 5. The question is 5, so I add the 5, and then I want to add the 4. When I add the 4, 1, 2, 3, 4, my final answer is 9. Now what are we doing? We're just moving the beads. We're learning how to move the beads, and notice how the beads move. Now if you see how I moved it, I added, right? When I move the beads to the horizontal bar, I'm adding. When I want to subtract, now I need to move it away from the horizontal bar. So we're showing how to add and subtract. And again, we're focusing on the add-in. So I have 2. When I have 2, I want to subtract 1. When I subtract 1, I'm just moving it away from the horizontal bar. So it's easy for the kids to see that we're subtracting. When we add 4 and I want to subtract 1, I'm just moving it away from the horizontal bar. Hopefully that makes sense. So we could do the same thing with the 2. When we do the 2, right? When we do the 2, I have 3, and I take away the 2. I'm just moving 2 beads away from the horizontal bar. That's all I'm doing. But notice when I'm looking at it, when I'm moving it, again, I'm moving it at the edges of the bead. I'm not like going all the way in and moving it, if that makes sense. So yeah. So we have 4, and I take away 2. I'm just moving these 2 beads. And it's the same thing with the 3. So we have 3, well, we could do it by Roman numerals, right? If I have 3, I have 4. If I have 4 and I want to take away the 3, I'm going to just move 3 beads. You could count 1, 2, 3, but we could be big people, right? Big people is doing this, 3. I know what 3 looks like. That's what 3 is, right? So all we're doing is we have 1. My final answer is 1. So I have 4, and I take away 3. That's all I'm doing. Take away 3. That's too easy. Yes. Abacus is simple to use, easy to understand. We have 9. I'm going to do 9, and then I take away the 4. Take away the 4 is only taking away the 4 beads. And then you can add the 4, so my final answer is 9. We have 5. Adding the 5 is easy, right? It's just the top bead. So all we're doing is if the answer is, the question starts with 0, and then I want to add the 5, now we have 5. So then if I have 1, or this one's 3, I have 3 on the abacus, and I add the 5, my final answer is 9. Thank you for the follow, Molly. So this is just my workbook, and it's very abacus specific. So the questions are very abacus specific, and we have a whole abacus framework. Okay, so what are we doing with the 6? Well, the same thing, right? When we have the 1 and I want to add the 6, notice when I add 6, it's 1 top bead and 1 bottom bead. I bring it together like that. If I have 2 already, it's still 1 top bead and 1 bottom bead, and you bring it together. That does not change. It doesn't change what color it is, because what we do is if we do this one, right, it doesn't matter the color, it just matters the item. So if I have 3 and I want to add 6, I'm moving these beads. So don't let the color of the abacus fool you, right? The colors of this abacus means nothing. It's just very helpful when you talk about the top bar or the blue beads. But the top beads or the blue beads, they work exactly the same. So when we look, we have the top beads. The top bead still has a value of 5. And we still have one, this would be 6, 5, 6, 7, 8, 9. It works exactly the same. No matter how big the numbers are, no matter how big the columns are, the numbers still work exactly the same. So I'm going to go back to the colorful one because I find it pretty. And then we have 7. Again, when we add 2, we add 1. And I want to add 7. Again, adding 7 is 1 top bead and 2 bottom beads. So we bring it together. So my final answer is 8. And then we could do it again. We have 2 and I want to add the 7. My 2, 1 top bead and 2 bottom beads, you bring it together, and my final answer is 9. So again, what we're doing is we're focusing on the added. We're not focusing on the result. We want to know, how do we add this 8? So if I have the question 1 and I need to add the 8, I'm going to add the 8. That's all I'm doing. So my final answer is 9. Anybody have any questions? Because if not, I'm just going to continue on. When we go through it, right, we have our takeaway, we have our minus. And again, if I have 7 and I add the 1, and now I take away the 5. When I take away the 5, I'm just removing the 5 away from the horizontal bar. Now what I did is I subtracted. Thank you. Yeah, not a problem. Let me know if you have any other questions. So we have 3. Our final answer is 3. What are we doing? Well, what we're going to do... What we're going to do is we're going to continue on, right? We have 1, and then we're going to add the 8. When we add the 8, we have 9. And then what we need to do is we need to minus the 6. When we minus the 6, again, we are taking away from the horizontal bar. Thank you, Yanni. I have no questions so far. But if that changes, I'll let you know. Fantastic. So again, what we're doing is we're moving it away from the horizontal bar. So we add 6, we take away 6. So we add the 6, it's 9. We take away the 6, it is now 3. This will eventually teach me how to do multiplication with the abacus. Yes, it depends on how far we can move the class. If it's just the 8 of us, then it'll be fine. But if there's more people, then it comes down slow. Hey, Jeannie. So what we're doing is we're doing this question here. If we add the 3, 1, 2, 3, I add the 6, right? Adding 6 means 1 top bead, 1 bottom bead. And then when we minus the 7 is the top bead and the bottom bead, and we move it away like this. So our final answer is 2. So again, what we're doing is we're looking at each number. We're not looking at the result. Because I know in elementary school, we always focus on the result. But in Abacus world, we always focus in on the specific number that we are looking at. So we look at 6. Can we do it? Yes, we can. Right? Can we add the 6?
Yes, we can.
So I add the 6. And then my question is, can I take away the 7?
Yes, we can.
Yes, so we can take away the 7. So my final answer is 2. All right, so that's 8. So now we have 8. 8 doesn't have a lot of questions, right? Because it's either 9, take away 8. And my final answer is 1. If I have 9, or if I have 8, if I have 8, take away 8, it is 0, right? You cannot take away, you can't have 7 take away 8. You can't do that, right? The reason why, because we don't do negative numbers. Like if I have 3 pencils and I want to take away 4 pencils, you can't do that, it'd just be 0. So in Abacus world, we don't do negatives. I mean, you could put it in your head, but then it gets confusing kind of quick. So that's it. That's it. That's how you do simple moving of the abacus. But here's a question. What happens when you don't have enough beads? That's a question. All right. So what we're going to do is we're going to start understanding this concept. There is this crazy concept that we're teaching the kids. We're teaching the kids how to make a 5. That's a crazy concept. So what? No, it's actually a very critical concept in abacus. You know, I'll tell you why. Because in the abacus world, we actually utilize this. We actually utilize this concept. I don't know where else where else in mainstream math do we use making of a 5? Does anybody know? I'm still trying to figure that out. Somebody said it's because it's convenient, but the other people said it's because we have 5 fingers, or 5 fingers, 5 toes, and all. It's easier to count. That still doesn't give me a reason. Why are we teaching the kids how to make a 5? You know what I mean? It's half of 10. Okay, well, that still doesn't tell me why are we teaching the kids how to make a 5. But in Abacus world, I'll tell you why we're teaching. I will tell you why we are teaching it. So if you notice, we have 4 plus 1 is equal to 5. We have 1 plus 4 is equal to 5. Let's keep this in our mind. So the question is what? Now, bear with me. If you can...
Now, open your mind to me, please. Open your mind.
So what we're doing is we're doing what we call +5. In Abacus world, we call it friends or small friends or what have you. But I'm trying to coin the terminology making the 5. Why? Because what we're going to do is we're going to utilize this 5. We're going to utilize this concept. What does that mean? Well, if I have 4, what we're going to do is we're not going to memorize 4 plus 4. How else can we teach the kids how to add a 4? Sometimes we use a number line, right? Sometimes we use a number line. Okay, let's do a number line. If I did a number line, and it'll be 1, 2, 3, 4, right? 4, 5, 6, 7, 8. And then you do 1, 2, 3, 4. You could do that. You could do number lines, right? What else can you do? You could do, somebody said you could do like pencils and pens. Okay, so you have pencils and pens, right? So we have pencils. So I have 4 pencils. I want to add another 4. Another 4, right? I have 4, 4, 4, and then we got to count it all, right? 1, 2, 3, 4, 5, 6, 7, 8, 9. You could do that. You could do that. Or what we could do is we can have this concept, right? How to make a 5. Notice I have 4 right here, and I want to add the 5. But to add the 5, I want to add the 4. Here's a better example. So I have 4 pennies, right? 1, 2, 3, 4. I have 4. 1, 2, 3, 4. Now when I look at it, I want to add another 4. But guess what? I only have a nickel. I don't know where you are in the world, but in America, a nickel is worth 5 cents. I have enough, but I only have it in a nickel form. I'm going to give you my nickel, but that's too much. So I'm going to give you my nickel, but that's too much. So what do? I have to take away the 1. So what happens? My final answer becomes 8. Now, is this a concept that kids can understand? Yeah, this is a concept that kids will understand. This is what we're trying to do. So in big people terminology, right, what we're going to do is we have this concept. We have 4 plus 1 is equal to 5. So what we're going to do is we're going to isolate the variable. When we isolate the variable, right, what do we do? How do we isolate the variable? To isolate the variable means we're going to put it by itself. So 4 is equal to 5, but 5 is too much, so we're going to minus the 1. So what happens is we're going to substitute this in. When we look, here's my question. I have 4. Because I have 4, right, I want to add another 4. But notice, I'm going to substitute plus the 5 minus the 1. I'm going to add the 5 and take away the 1. So my final answer becomes 8. Does anybody have any questions? So that is what we're doing. What we're doing is we are taking this concept of how to make a 5 and we're utilizing it. We don't want any freeloading numbers. So what we're going to do, we could do it again. If I have 3, I have 3 on the abacus. Whoa, I have 3 on the abacus. When I have 3 on the abacus, again, I'm not going to memorize doubles minus 1 or doubles plus 1, right? I'm going to utilize this concept that we already know. We already know 1 plus 4. 4 plus 1 is equal to 5. So what are we going to do? We're going to isolate this variable, right? I'm talking to big people, right? But if I was talking to little people, I'd say, like, remember what plus 4 is. Plus 4 is plus the 5 minus the 1. So all I have to do is plus the 5 minus the 1. We are now given directions on how to move the beads. We need to memorize this. This is going to be very critical when we start going into bigger numbers. What do you mean bigger numbers? Well, okay, so we know this concept, right? We understand it. Plus the 5 minus the 1. So let's take it one step further. I will show you. Let me see if I can find it. Oh, here it is. Here it is. So here is my number. Where's my number? Is this it? This is not it. Oh, here it is. Okay. So here's my number. Here is a bigger question, right? That's the bigger question. So when I have 1, 3, 5, 7, 8, right? I have 13,578. And then what am I going to do? I'm going to add 200. I'm going to add 24,311. So the first thing I'm going to do is, can I add the 2, right?
Yes, we can.
Yes, we can add the 2. So now we're here. Can we add the 4? No, we don't. We don't have any more beads to add the 4. But wait a minute. We know this concept. Plus the 5 minus the 1. To add the 4 plus the 5 minus the 1. And then we go back. I want to add the 3. Is there any beads to add the 3?
Yes, we can.
Yes, we can add the 3. 1, 2, 3. And then we add the 1. Whoops. And then we add another 1. So then my final answer becomes 37,889. Then that's it. So what we did is we just understood our numbers, how it looks on the abacus, and then whatever number we need to add, we utilize, and now it becomes scalable. Does that make sense? So what I just showed you was how easy it is, right? This is really easy. That's not the problem. The problem is understanding the fundamentals. As long as we understand the fundamentals, then everything can scale. So if we have this, right, we have 2, so I'm going to have 2 on my abacus, and I want to add the 4. When I add the 4, I'm sorry, let me go back. I add 2 on my abacus, right? If I have 2, 1, 2, 2 pennies. But then I only have a nickel. I only have 5 cents. To have 5 cents, I'm going to give you my 5 cents, but that's too much. So I'm going to take it away. So I'm going to give you my 5 cents, but that's too much. I'm going to take it away. So my final answer is 6. So the kids will start to understand, and even us, will start to understand how it becomes an exchange, like a trade-in, right? So we're trading it. And this is the beginning parts of how to make a 10. But the first thing we need to do is we need to understand how to make a 5. And that is why we utilize this concept. We, in the abacus world, actually utilize this concept, and we power it up. And when we power it up, right, we can do some modifications.
You need modifications. Modify.
So, how are we doing? Everything okay? Everybody, does that make sense? So we can do it again with the 3. When we do the 3, right, we have the same thing. But this time, we have to different pairs. Our pair is now what? Is a 2. How do you make a 5 with the 3? Is you use the 2. So when you do it, I have 4. On the abacus, I have 4. And then what we're going to do is, again, we're not going to memorize doubles minus 1 or add 1 or whatever. We're not going to do that. What we're going to do is we're going to understand how to make a 5. So what do we do is I have my 4 and I want to add 3. So I have 4 on the abacus. I wanted to add 3. But the problem is I only have a nickel. I only have 5 cents. Because I only have 5 cents, what am I going to do? I have enough money, but I have to have change back. So I'm going to give you my 5 cents, and what happens? I got to take away 2. So I'm going to take away 2 pennies. So here, same thing. I add the 5 and I take away the 2. So my final answer is 7. Is this complicated? It's not complicated. It's just a different way of thinking, right? And so we could do it again. So here, I have it in this book where I have 5 cats in a tree. I have 4 on the abacus, right? And do I have enough beads to add the 3? No. So that means I got to go to the 5 cats in the tree. So I go to the 5 cats in the tree and I take away 2, right? I grab 3 cats, but then 2 cats run away. So my final answer is 7. Yeah? And then we could do it again. Well, what if we do 3, right? If we substitute 3, what's the next one? Well, the 3, we can substitute 2. It's the same thing. So, but the question is if I have 4 and I need to add the 2. So if I have 4 and I add 2, but I only have a nickel. If I only have a nickel, right? If I only have a nickel, that's too much. I'm going to give you my nickel, but that's too much. So what do? I have to take away 3. So my final answer is 6. Anybody have any questions? Whew. Yanni, you okay? I don't know why you're crying. Don't cry. All right. Anybody have any questions? All right. We can continue on. Okay. So we have, and then 1. 1 doesn't actually have a lot of questions. 1 is just 4. And that's kind of easy, right? Because it's the opposite. It's not the opposite. Okay, so what's going to happen is after we add, we know how to add. If we know how to add, we will know how to subtract. What does that mean? Well, remember, if I add the 1, I can subtract the 1. If I add the 2, I can subtract the 2. Now, it's the same thing with the 5s. What? Really? Yeah. It's kind of cool because we want to make the 5. It's harder than I thought, but I know it's fast and accurate. What's harder? The exchange? How to make a 5? That's harder? Thank you for the comment. Lush. Using the abacus. Using the abacus is harder? I'm just trying to figure it out. The comment. Because I know comments are different, as we speak. So using the abacus is harder. Do you know how to read it? So when we read the abacus, we have 1, 2, 3, 4. And then the top beat is a value of 5. So right now what we're doing is we're doing a review. So this is 5. The top beat is always 5. And then we have 6, 5, 6, 7, 5, 6, 7, 8, 9. My math is common math, so it's different for me. Yeah, your math is mainstream math. That's all I needed. Okay, cool. Okay. So then, we're going to do a -5 as I continue on. We're going to do the takeaway 5. Oh, so here's your common math. So my question is why are we teaching the kids how to make a 5? You might be the perfect person to ask. Why are we teaching kids how to make a 5? What is the point? Okay. I would like to know, why are we teaching the kids how to make a 5? I know why we teach a 10, because we need to carry over, but why are we teaching kids how to make a 5? That's my question. But the numbers have no points, just facts. Once you know, you kind of know. That's not the answer. Why are we teaching the kids how to make a 5? I love math too. I love arithmetic. But I would like to know, what is the point of teaching them how to make a 5? I know the point of why we teach them how to make a 10. It's easy. Our fingers are easy to count. That's it? Because it's easy? Our fingers are easily count. That's it? Okay. That's still not a... Why not? We have 5 fingers on each hand, 5 toes, and 5... Yeah, I don't know. It makes sense, but that's not a why. I can tell you why on the abacus, right? Because if I have 4, as I said before, if I have 4, my question is if I only have, right, if I have 4 on the abacus, I have 4 on the abacus, I'll give you an example. Here's my money example, right? If I have 4, I only have a nickel. All I have to do is exchange it. I have enough money for 4, but I only have a nickel. I only have 5 cents. So I'm going to give you my nickel, and I take this away. So my final answer is 8, which is better than memorizing doubles, right? Because doubles is not a very specific. So I add my 5 and I take away my 1. This is why I am teaching how to make a 5. But if you're telling me that because we have 5 fingers and 5 toes, conceptually, there is no point. It's great to have 5 fingers and 5 toes, but when we do math, why are we teaching the kids how to make a 5? Right? It goes hand in hand. If I have 4 in the abacus, I'm going to give you 3, right? I want to give you 3, but that's too much. I have a nickel. So if I give you my nickel, I'm going to do exchange. If I want 3, I have to take away 2. So then I do an exchange, so my final answer is 7. Another question is why we have pennies. We still have to add up to 5. Another question is why have pennies? Well, we have to have pennies because it's single blocks, right? So it'd be like single blocks. It'd like be these blocks, right? Why do we have items? That's not a really reasonable question, right? Just like we have pencils. We have 4 pencils, right? We have 4 pencils. We need every individual one. That's why we have pennies. I'm using pennies as an example. So, but yeah, I mean, it's just an interesting concept. I just find it interesting that it doesn't. I mean, we don't have 2 pennies, but we have $2 bills, right? We don't have. Oh, what was that? We don't have 2 pennies. We don't have but we have $2 bills, which is interesting, right? Anyways, I see. This is when I'm confused, since you need 5 to the equation to get there, so exchange. Yes, we just need the 5 to exchange. We're making the 5. Yep, that's all it is. And so when we're looking at it, I'm not trying to discount it, right? I'm not trying to discount common math. I'm just asking why, right? Coming into a live in the middle of a question, there's a foundation that needs to happen. Everybody needs to have a foundation before they can actually have a question or what's going on. So yes, you're right. You need this 5. This 5 is what we're using. So when we have 4, right? I know as an adult, right? We know 4 plus 4 is equal to 8. We know this. But if I'm teaching children, they don't know, right? You could say, well, just add another 4. Add another 4 pens or pencils, whatever, right? We can add another 4. Okay, fine. But you know what? This is harder to see. We have to count it. 1, 2, 3, 4, 5, 6, 7, 8. Whereas, if we start with them to do critical thinking, right, we can add the 5, take away the 1. And my final answer is 8. So when we're looking at it, we have an easy way to explain it. So we could do here, right? Let me take it one step further, right? Let's say we have 80. Let's say we have 40 pens. Shit. Okay, fine. We'll do 40. 1, 2, 3, 4. I have 40 blocks, right? 40 pens, right? Now it's getting a little bit much. Let's take it even one step further, right? We got to add another 4 to this. Okay, that's fine. I just have another 4. Now we talk about management problems because now we have more items. Whereas here on the abacus, I have my tens, my ones, my tens, my hundreds, my thousands, my 10,000, which is fine, right? All I got to do is just add the 5 minus the 1. And then I have 80. I know this is 80 because every column is a place value, right? Every column is a place value. I could take it one step further. If I did 400, holy shit, man, I got to get 400 of these? It just gets bigger and bigger and it becomes unruly, right? So what I'm showing you is the very basic. I forgot, right? What I'm showing you is the very basic, but it is scalable. If that makes sense. Okay, so we're going to go to minus the 5. I don't know who else is here. Whoever is here, let me know. We can continue on reviewing. Or just have a conversation with Blush. Which is a great conversation. I don't mind this at all. Oh, hey! Hey, Char! Thank you, user 397. Hello. I don't know. I don't know. It's just a symbol. Hello. Okay, so then I'm going to continue on with minus the 5. Do you want me to do minus the 5? Because we could do that too. I just got settled into my desk. Oh, oh my god. I definitely need the chill vibes here. Oh, AI TikTok God. Thank you so much for sharing my live. I see you. I see you. Blush, I'm not trying to pick on you. I'm not trying to pick on you. I'm just bringing in some conversation. Well, even AI loves math. Yeah, no, I'm not. I hope you didn't feel like I was picking on you. I'm just curious because I was trying to relate abacus to mainstream math. That's why. Go for it. Love combos. People don't ask. People ask. People ask, and I do answer. User 397 asked, and I was able to convert user 397. People ask, but I'm always interested to start like different kind of conversations to expand on my vocabulary as I go through. But that was the big thing, right? Like, why are we teaching kids how to add the 5 if we're not utilizing it, right? I'm now a believer. Oh, I need to get another sound bit on that. I only have this one.
Welcome to the real world.
And I only have this one.
Now, open your mind to me, please.
I need it.
Open your mind.
I need to get one that's saying that I'm a believer. That'd be hilarious. I always love the sound bits. Thank you so much, Char. Thank you so much. Oh, you know what? And I was thinking a little bit about the previous person yesterday about how my font is bigger. And I realized it might be because my camera is zoomed in. So, in literally comment 5 to teacher, don't ask don't why always thought it was just easier. Yeah, but I always... You need the... Okay. I will get the now... Yeah, I will do that. Knowing is half the battle. That's a good one. I think... Yeah, I can see that. Okay, I'll get that one. In common math, yes, I know we go by 5s and by 10s, and I know it's easy, right? Like, we can do it in Abacus, right? 5 plus 5 plus 5 plus 5 plus 5. And you can see the number pattern, which is kind of cool on the Abacus. So it's interesting to see number patterns on the Abacus. So when we look, right, whereas in mainstream math, we read it. And it's different because when we read it and when we experience it. So when we're looking at, excuse me, we're looking at the 5, this is 25, and then we add another 5, we go 1 up, 1 here. And now we have a pattern. Notice my pattern. I add the 5 and I what? Now I need to add another 5. I go up here and I take it away. And then I add the 5. Oh, that's 45. And then I add another 5, which is this, which is 50. So now I have to add another 5, and then I have 60, and then add another 5, and then I do 70, and then I add another 5, and then we have 80. So it's interesting to see it on the Abacus because it's more visible. It's more tactile. Hey, CompuBear, welcome. Thank you so much for the rose. Yeah, and I know there's the finger abacus. I don't know how to do that. I don't teach finger abacus. I only teach Soroban. And that was the one thing. So what we're going to do is, review how to make a 5. That's a lost number on the abacus. It's a lost number on an abacus because it's really just a 0, correct? It is, but it's not a lost number because it's like a placeholder. Yes, it's more like a placeholder, right? Because even when we write, right, in conversion, when we convert it, we even do it when we're writing. 5 is very different than 50. 0 is still a placeholder. 50 is very different than 500. 0 is still a placeholder. So on the abacus, now we have our columns. 5 is our 5 is our 1s. 50, right, is our 1s and our 10s. 500, right, is our 500 with our place values, or placeholder. So our 0 is still a placeholder. Knowing that we are here on our 1s, we still have our replacement. You could say 5, any of these, right? But it depends on the placeholder of the 0. Just like when they teach, in school they teach 0 the hero. Why are we teaching 0 the hero to kids? It's because we don't give them the understanding that there's a placeholder, right? Remember 0 the hero? 0 the hero. There was a whole like unit on this. 0 the hero. And I'm like, why is there a whole unit on it? So it's exactly what we have here, right? And we don't need to have that. Schoolhouse rocks. Oh, is that a schoolhouse thing? I didn't know that. Because if it doesn't exist, you forget about it. You forget about it, but you don't forget about it on the abacus. Because on the abacus, we keep every place value. We know from here, right, is 9. And then we know that this is 90. Because we know that this is where we start, right? We always know where we start. And it's different, right? It's different on the abacus than it is in paper and pen. And that's the difference. Because we have to write it out, it's different than using it on the abacus. And that's why I believe in the abacus, but more than the paper and the pen. I mean, we even talk about, I even do a comparison of like new math and abacus, right? Didn't know you went to decimals. Always thought it was whole numbers. Yeah, decimals happens between here and here. But when we look at it, right, you can have any one of these ones indicator and then the rest would be decimals. So it just depends on how big the number gets. But what the abacus does, it helps you hold the number. As long as you remember where you start from. Just like you know where your home is. And so I going back to the original comment was, it's harder than it is. It's actually not that hard. You just need to see it. I hate new math. It makes me reverse all my knowledge and I can't get answers correct. New math is just a different way of thinking, but the problem is you actually have to write it out. So if I had this one question, right? I had the one question. Let's say we did 34 plus 14, right? So one person talked about new math. I don't know. They did number bonds. So you did this, and then you break it up into number bonds. And I understand why we do new math. It's because they want the kids to see the numbers, right? So what did we do here? We broke it up. But the difference is it's on paper. Here, if I did it on my abacus, I just do 30 and I do 4. Now what's next? I have to do, break it up again. I go 10 and then 4. I did my daughter's math. I teach her to write it out. I did it with 4 times and I got 1 out of 4 correct. What is the question, if you don't mind me asking? So then here, continuing on my thought, I'm just going to add these two together. So then this is 4, and then I add these two together, and then this is 8. And then you have to add these two together, and you get 48. Whereas on the abacus, right, we have 1. We know how to add the 1. We just add the 1. Now we add the 4. When we add the 4, what do? We know how to add the 4. We add the 4 with this concept. This concept is plus the 4 is equal to plus the 5 minus the 1. So we're going to plus the 5 minus the 1. So my final answer is 48. But showed my way much faster, quicker, and correct. So I don't know why my brain hates it. I hate new math. New math is different for us as adults because we've memorized it and we've seen it. New math is good for new math and abacus. You know, funny, this is abacus. It's just written out, that's all it is. New math, that's how I see it. I don't teach new math, I teach abacus. So, it's a little bit of a puzzle why we have to give them all these other strategies to add when we can just use this. When it comes to shapes, it's even worse. I see new math as a calculator way to do math. Yeah, I could see that. You know what I don't like is they do the arrays. I don't like when they do arrays because it gets kind of cumbersome. When we do abacus for multiplication, when we could do that in a little bit. it was made to beat the calculations. Yeah, I guess so. But I think on the abacus in the abacus world, it's easy to see how the numbers are moving. So, okay, let me go back. Um, so here's my question. My question is 8, and again, these are very simple questions, but this is the fundamentals. It's like in Karate Kid where you wax on and you wax off, or the other one where you take the jacket on and take the jacket off. What I'm showing here is how do we move the beads. So again, if my final question, my question is 8, and I want to take away the 4, that's what I'm going to do. So to take away the 4, I know I'm going to minus the 5 plus the 1. I have now been given directions. All I got to do is minus the 5 and plus the 1. And my final answer is 4. So when I look, I have my substitution. This is where I'm substituting. Minus the 5 plus the 4. So my final answer is 4. And it does it again. We could do it again with like 16. So if I have 16, take away 4. Remember, I don't have any beads to take away the 4. I'm over here. I don't have any beads to take away the 4. So what do? To take away the 4, I need to minus the 5 plus the 1. So my final answer becomes 7. I isolate the column, right, with my column isolator. I isolate the column because I want to be able to know what I'm looking at. Looking at all of these columns might be a little bit more cumbersome, like it's a little bit more difficult to see. So what I do is I usually, because that's what we're doing, is we're only looking at this one number right here. We're not looking at the whole thing. We don't need to look at the whole thing. Just like with this one question, right? Even when we do the one question, right? We don't do the whole thing. We go number by number. In mainstream math, we do this number first, then we do this one, then we do this one, then we do this one, and then we do this one. Whereas in Abacus, I went this way. But the numbers, the concept, fundamentally, it's still the same. We go one number at a time because you can't do everything at once. So when we're looking at it, we do 15. Here's the question 15. If I have 15 on my abacus and I want to take away the 4, what am I going to do? I need to minus the 4. I don't have any beads to take away the 4. So now what we're doing is we're installing critical thinking. How do I take away the 4? I am going to utilize what I have. So to take away the 4, I can utilize this 5. Minus the 5 plus the 1. My final answer is 15. Which is very different than the way we talk about it in school. Now we're doing an exchange, but we also understand our building blocks. So we can do, and then after 4, we can do 3. 3 is exactly the same. Notice when I add the 3, so if I had 4, and I'm adding the 3, it's plus the 5, take away the 2. I have 7. Now if I did the reverse, right, why left to right what if we had to carry one? Whoa, that's a good one, Comfy Bear. Let's do it. So let's do 7, right? Take away 3. Take away 3 is minus the 5 plus the 2. All right. So one of the questions. So we're done with this. Let's go into doing carrying over. Though that's like okay. Let me see if I can find a number. I need to go here. Is it here? Oh, here. Let's see how well we do. Okay. Let me get a new piece of paper. Okay. So what we're going to do is we're going to do some adding. These are going to be big questions. So let's do 83 plus 24. Okay? So what we're going to do. Did you make that? Not yet. I was looking at it and I realized I'm not comfortable with it yet. New math has invented by a guy who beat the calculator figuring out the answer. guess. Yeah, but new, whatever. I'm sorry. New math. Okay. So what are we going to do? We have 83, 5, 6, 7, 5, 6, 7, 8, and then 3. Oh, I guess I should have done the other one. That's fine. So you could add the 4. So you add the 4. You could do it this way. You could do it this way, or you could do it this way. It's up to you. I usually go from left to right. So I'm going to add the 2. When I add the 2, do I have enough beads? Hello, RTX. Hello again. Okay, I'm going to add the 2. I don't have enough beads to add the 2, so what am I going to do? To add the 2, I can minus the 8 plus the 10. What am I looking for? So the one thing that we're going to do is we're going to understand, we're going to plus the 2. To plus the 2, we're going to minus the plus the 10, minus the 8 plus the 10. We're always going to go to the column to the left. Does that make sense, Comfy Bear? So when we do it, we go minus the 8 plus the 10, minus the 8 plus the 10. So we minus the 8 plus the 10. And then here we're going to add the 4. When we add the 4, right, what do? Can we add the 4? Plus the 4 is equal to plus the 5 minus 1. So I'm going to plus the 5, and I'm going to take away the 1. So my final answer is 107, just as Blush mentioned. Did that answer your question or no? I don't think it did. So we could do another one. Let's do another one. Let's do an easy one. Let's do 85 plus, I don't know, 85 plus 45. How about that? Maybe we'll do that one. Maybe we do that one. I'm still confused. Okay. So let's try it. Sorry, I'm thinking. Okay. Okay, so we're going to do 85. We do 80 and we do 5. Okay, I'm sorry. Let me go back to the original question. Why left to right? What if we have to carry the 1? Okay, got it. So, I'm going to add 4 here. If I add 4, right? If I add 4, I'm sorry, my question is 45. If I add 4, what do? Okay, this is where we have to go through our process. We want to add the 4. CompuBear, is there enough beads to add the 4? Is there enough beads to add the 4? No. Okay. Then what do? I have to go here. Can I use the 5? Can I use this 5? No. I'm already using it. I'm already using the 5. Right? No again. So then I have to go down to here. And I have to plus the 10. Plussing the 10. Now let's decompose this a little bit. Plussing the 10. When we add the 10 minus the 6. If you noticed, let me move this. Right? Remember, when we have 9, right? Can you see that? We have 9. How do you make a 10? Making a 10 is 1 and a 0. 1 and a 0. That's how you make a 10. That's what we're going to do. 1 and a 0. That's what we're going to do. We're going to add the 1 here and we're going to have a 0 here. So that's what we're going to do. When we add the 1 and we have a 0, we are not done, right? We're not done. We added too much. So what do we have to do? What is the partner of 4? The partner of 4, right? We're here. So what we did is we have to plus 4 is equal to plus the 10. And then that's too much. I added 10. That's too much. I need to take away 6. So I need to minus the 6. Does that make sense, CompuBear? Okay, good. So then I do it again. I need to add the 5, right? To add the 5, can I add the 5? No, I don't have any more beads to add the 5. What do? I need to use this. my formula that I'm using is plus the 5 is equal to plus the 10 minus the 5. Again, plus the 10. What is plus the 10? Remember, 1 and 0, 1 and 0. When we do it, we want to plus the 10, right? 1, 0, and then take away the 5. So my final answer is 130. Right? So what did I do? So this one was this one. This one was this one. Yep. And so, when we are working with it, we go through it bit by bit. Oh no, that's the wrong one. There's extra problems if you want. But that's what this is. That's what this is. So what I did here was I tried to explain it just as I did. So we teach in mainstream math, we teach how to make a 10. Once we know how to make a 10, maybe once you understand the 5 sheets, maybe once you understand the 5 cheat sheet, it's quick. Actually there's two. There's 2 cheat sheets. One is how to make a 5, and then the other one is how to make a 10. Once you know how to do both of these, then it's scalable. But you have to know how to make a 5, and you know how to make a 10. I'm about to call you, teacher. So, what we're going to do is let's continue on how to make a 10. So remember, what we're going to do is understand where our 10 pairs. With our 10 pairs, we have our pairs. Oh, here it is, right? We need to remember these. This is what we're going to do, right? We know we are teaching the kids how to make a pair. This makes sense to me, and the reason why we use it, right? Because in Abacus, we use the 10. That just means we're using the extra side. So it actually doesn't matter. You could do 50 plus another 50. It doesn't matter where you add the 10. Does that make sense, CompuBear? Because now the 10 is agnostic. We do not say, okay, so here's the question. If the question is 50 plus 50, we do not say 50 plus 50 is equal to plus 100 minus the 10. We do not say this. Why? Because we're focusing on the one column. So when we're focusing on the one column, it doesn't matter where it is. It just matters what you're trying to do. It will always be plus the 10 minus the 5. So if I have 5 here, it will always be plus the 10 minus the 5. Plus the 10 minus the 5, and my abacus will keep my answer. Now I have 100. Okay, good. Right? So what is I'm trying to do is I'm trying to be as simple as possible and yet be versatile, right? We're trying to scale it. So it doesn't matter where we are in the whole grand scheme of things, right? We could do 105,602, and then we could do 2,531. Let's do that. If we're adding it, right? It doesn't matter where we are. So if I did 1,562, I'm still going one number at a time. I add the 2. Can I add the 2? Yes, I can add the 2. I need to add the 5. Can I add the 5? No. There's not enough to add the 5. What do? I know if I plus the 5 is equal to plus the 10 minus the 5. I'm going to plus the 10 minus the 5, plus the 10, 1, 0, 1, 0. So I add my 10. I need to take away the 5. And then I need to add the 3. Is there enough? Yes. If there's enough for 2 or 1, I add my 1. So my final answer is 4,093. Because what did I just do? Now this is position agnostic. I'm gonna trademark that term. Position agnostic. So that's one thing. I know some people were doing this. I'm like, no. We don't say 50 because now we are going too much. We're not looking at the whole thing, because if you start from here, right, or even if the number gets bigger, right, you're going to get way too big. And it gets confusing. We don't need to add these extra zeros. We just need to go to the very fundamentals, the manageable chunks. As we go to the manageable chunks, then it'll be easy to work with. Just like when we do multiplication. Multiplication is in manageable chunks. We don't add the extra digits, add the extra zeros, because there's no need. Right? Cool. Yeah. Let me know if you have more questions. But we can continue on with like how to make a 10. And so that's the thing, is understanding when we make a 10, right? Let's do 8. 8 is always a better one because it's not too many ones. So here is 7. When I add the 7, I have 7. I want to add the 8. I know when I add the 8, my partner of 8, what's my partner of 8? If I can find, there it is. My partner of 8 is 2. So what do? Well, that is when I go to my formulas, right? I go to my formulas and I power it up. When I power it up, I do 8. I isolate my variable. When I isolate my variable, I'm going to have 10 is equal, 8 is equal to plus the 10 minus the 2. So I'm going to have plus the 10, I'm going to take away the 2. When I do that, I substitute it. I substitute it in. So it's plus the 10 means what? 1, 0, 1, 0. And then I take away the 2. And I take away my 2. My final answer is, oh, I did that wrong. 16. It should have been 7. So if I did 7, I can do it again. Plus the 10, 1, 0, and then take away the 2. Take away the 2. And my final answer is 15, right? I did 8 plus 8. But then that's what I did with the asteroids, right? The asteroids is supposed to be the belt. That means that if I don't have enough beads to add, right, I go to the asteroids and I use the asteroids to help me. So I was trying to make it a little bit more story-based, like kind of, yeah. And so here, if I did 4, I could do it again if I have 4. I just realized I abacus it all the way through my head, but watching the abacus confuses me. Yeah, but don't forget, it's still a very new thing for you, right? So when I look at it, I have 4. I'm going to add the 4. I'm going to add the 8. To add the 8, there's not enough. I need to what? I need to add the 10. So I'm going to add my 10. I have to go to the asteroid belt. When I go to the asteroid belt, right, it's, you know what it is? It's unfamiliar, Blush. But don't forget, I've been teaching for 20 years. I've been teaching abacus for 20 years. Okay, so I go to the asteroid belt. I'm adding 10. That's too much. So I need to take away 2, right? Because I'm only utilizing 8 here. If I'm only utilizing 8, right, I need to take away 2. When I take away 2, I am here. My final answer is 12. Teachers in my family for 20 years, too. That's cool. Do I have a beginner class? I'm so lost. Here is the, hello, Simbayan. So let's do a review. Thank you, Reeves. Welcome back. Thank you so much, Reeves, for the rose and for the heart me. Wow, I didn't see you there. Okay, Simbayan. Simbayan, what we're going to do is we're going to count on the abacus. Let's do a review. Let's do a review. Okay, wait. What are we doing? I got to do a review. So let's do a review. So when we're looking, right? Teachers are amazing when good. 0. 0, that's what 0 looks like. 0 just means that none of the beads are touching the horizontal bar. That's what this is. This is a horizontal bar, and then none of these beads are touching, right? That's what this means. So when I look at 1, when I have 1, I have 1. That's what this is. 1. These are 1. 1, 1, 1, 1, 1, 1, 1. These are all 1s. Doesn't matter what column you are. It just matters what the number is, right? And what we're doing is we're just reviewing what the numbers are. So here is 2. If you notice, 2 is just the 2 beads. That's it. 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, right? And then we have 3. 3 looks like this. It's easy. Make sense? Simbayan? So we have 3. All of these are 3s, and then we can do 4. 4 just looks like that. Notice none of the top beads are touching, because what happens? The top bead is a value of 5. That's what 5 is. So when we're looking, the top bead is a value of 5. We have 5. And then after 5, we have 6. 6 looks like this. That's what 6 looks like. And then 7. 7 is just this. 7, 7, 7, 7, 7, 7, 7. So that's what 7 is. And then we have 8, 8. And it looks like it's very familiar, right? The pattern is very similar. Because what happens? This is 3 plus 5. So we have 3 plus 5. And then we have 9. What does that mean? 4 plus 5 is 9. That's all it is. That's counting on the abacus. But I'm using all of it. So what about 10? Well, now we have to start talking about place values. We have to talk about place values. And I have to find my... Oh, here it is. So now... a date, I'm live. Yes! So now what we're going to do is we're going to figure out our place values. Every column is a place value. So we have our 1s, our 10s, our 100s, our 1000s, our 10,000. So you might be wondering, why am I over here? I have this dot indicator. This is my 1s indicator. This indicator is like a Pokemon.
Pokemon, I choose you!
You can choose one, or you can choose this one.
Okay, Charizard, I choose you!
If you choose this one, then everything would be shifted over. I have my 1s and my 10s, and then this over here would be my 100s. But notice I have no more columns to have my 100s, right? I have no more digits. I have no more columns. But I can have all of these as my decimals. These are all my decimals. So this is why I choose this one over here. So now I can shift it over, and it would look like that. Now I have my 1s, my 10s, my 100s, my 1000s, my 10,000. When I look...
Pokemon, I choose you!
I can have my decimal. My decimal sits between my 1s and my 10ths. So now I have hundreds, right? Just like money. If I had 15 cents, it'd be 15, 1 and 5, right? 15 cents. Cents is what? 100 cents, right? Make sense? Cool? Okay. So that is the review. And that's, and then as we go through, we start talking about formulas and everything. And I have books. I've got books and I've got jokes. Okay. How are we doing? Thang, you have any more questions? Oh yeah, Simbayan, not a problem. That's the easy version. Easy version? It's the quick version. It's the beginning version. All right, CompuBear, how's it going? Are we doing more adding? You want to do more adding of the 10? Do I get the abacus with the book? Not yet. I haven't figured that bundle out yet. I was thinking about it. I just haven't built that set to have it as a bundle. But yeah, that would make sense, right? To have this. I guess so. Yeah, that would be good. Yeah. Is it for you or for your child or a person that you're looking for? How old is the child? This might be a little bit too young. This one was specifically for kids that are 3, 4, and 5. It all depends on how old or how young the kids are. I'm still in the process. Yeah, I'm still in the process. It's for me. I want the books and the abacus. It's for my son. Okay, the preschool one might be good because we start talking about actually counting forwards and counting backwards. And so this one is about bead recognition and the number recognition. So here's a little overview if you wanted to take a look. So here's the overview. In here, this is activities on like what does 0 look like. This is what does 1 look like, and how to trace it and how to find the number. And what I'm doing here is I'm just trying to explain like the numbers here and how this is, and then after we know the bottom numbers, the way I broke it up is all the bottom numbers. After the bottom numbers, then we have activities for the bottom numbers. So I just kind of mix up the numbers, like, here's the number, 1, 2, 3, 4, write the number, and then find the abacus. And then here is a path. So here's the numbers, and then you have to find the 4 here, and you have to trace the numbers. Or you have to write the numbers of the abacus. So this one is 3. And I do it again here, and this is a draw and a match. And then after lesson 1 is lesson 2. Lesson 2 goes from 5 to 9. And so, and that's what we're doing, is we're focusing on the numbers, right? I go number by number just to make sure that they understand. And then there's like pixel art. This is just bead and number recognition. And then there's more activities. And then after the activities, it goes to counting forward, and then we are counting backwards, and then we come, what's between the number, what's the number in between? So I give you the number here, I give you the number here, so this is 1 and this is 3, and then they have to figure out what the number in between is. And then afterwards, it's what comes before and what comes after. So if I give you the number 4, what comes before 4 and what comes after 4? And then after that, it's bigger than and smaller than, so it's about comparing. And then after that goes into adding and subtracting. So in the beginning of my live, I started going into how do we add and how do we subtract on the abacus. And in the abacus world, we focus in on the add-in. We don't focus on the result. We don't say, how do you make a 6? It's like, the question is always going to be, how do you add 1? And so every number has a specific lesson. So when we look at this, right, it's plus 1. And then after you add the 1, you know how to add the 1, then we add the 2. And then after we add the 2, right, I mix in with the numbers too. But I also have like some abacus to show you as well. This is so cool. Oh, thank you. I appreciate that. This book was more for young kids in mind because we didn't have this in regular abacus world. In the abacus world, the questions are very boring and dry. So here's an example of an abacus workbook that I found. This was given to me by a retired abacus teacher. And so I looked at this, and this is 60 questions of boringness. So what I was trying to do is I was trying to make it a little bit more exciting. And so I was trying to be more interactive. So this is only adding and subtracting simple, right? We don't go into the formulas yet. So, and then we do the minus. You know how to add, you will know how to subtract. You need to know the balance. And again, this is, adding in the 5, and it's broken up into those sections. So we do the minus. After this, it goes into how to make a 5. And that's what we were talking about. I'm not sure if you were in on that. But then it goes into this. And I didn't make the books too big. This one is because I wanted the kids to feel accomplished. So here is an example of my book. This is about like less than 100 pages. But the content is understanding how to make a 5. So one thing is in school, we're teaching the kids how to make a 5. We have a 5 frame, right? And like we do is how do you make a 5? 4 plus 5. Do you have YouTube? Yes, I do have YouTube. It's in my link in my bio. And I'm there right now. I'm there right now. So if you have a question and it gets filtered out, you can ask me on YouTube. So Simbayan. Okay, so what I'm doing here again is how do I add the 4? I'm very specific when I'm asking questions because you know, what we want to do is we want to add the 4. Here are the different example questions. And then you go into how to add a 3. And you, again, is a different formula, right? And I show you here how to add the 4 and how to add the 3. So I give you examples, and I give you, yeah. And then how to do a 2, and then how to do a 1. And then you're done with this. But there's now practice. And all of these questions are very specific to how to make a 5. So when you have the maze, I want to answer the question, and I have to follow the answer. Follow the answer to the next one. They have to answer this number, and then they follow the answer to the next box. And as they go through, I also have a color by number, and then what else do I? Oh, word problems. I have word problems, and I have hidden number. And again, we focus on only specifically on how to make a 5. And then this is color by number. And tic-tac-toe. I thought that was kind of cool. Yeah, it's like a puzzle. Yes, it is like a puzzle. And I enjoy puzzles. But yeah, and so when we understand how to make a 5, right, this is all practice, how to make a 5. I think what I want to do is, when you start going into the practice mode, if you want to start with the second book or the third book is how to minus the 5, right? And it's the same thing. I go through, we review how to make a 5. After we make a 5, right, then we start going into how do we minus the 4. And again, we minus the 4 is minus the 5 plus the 1, which is very similar. And now what we're doing is we're compounding our knowledge. We're compounding our knowledge. So we have plus the 4 is equal to minus the 5 plus the 1. Whereas when we add the 4, it's plus the 4 is equal to plus the 5 minus the 1. Yeah. And so we start going through, and again, it's about, you know, activities and just trying to be more interactive. And then this is color by number. This one is like flower based, and so they're a little bit more themed. And I have a spinning of the wheel, and this is more just activities, plus the tic-tac-toe and so forth. And then once they're done with that, then they have extra activities to work through. So here is a petal puzzle, whereas you answer the question, and whatever the number is, you have to find the bud to go with it. So every number, there's a petal for every number, and then there's the hidden word, and then there's word problems. And again, I have mazes, and I have the hidden word. And when we're done with that, I give you answers, just in case you don't know. I give you answers, and then after adding of the minus the 5, we plus the 10. I love your wipe off book. Oh, that one? This one? This one is only available on my TikTok. It's over here. And you have 2 versions. You can either get one that is not bounded, or you get it bounded. But yeah, this one, that's what this is. And so I like to use it when I teach you guys. And I added more things to it, which is cool. I added these tabs. This is the actual product. So I add the tabs. And then if you notice there's a plus 4, because there's a plus 4, right behind it is the minus 4. So you have a 1-to-1. And then so it doesn't matter where you want it. Thanks for everything. I'll be back. Have a wonderful day. Oh yeah, you too, Blush. Thanks for the conversation. That was really good. Thank you so much. So then this is how to make a 5. After making a 5, you can make the 10. After making the 10, it's the same thing, right? You add the 10 or the 9. You can add the 9 or add the 8, right? Or add the 7. Or if you need the minus 7, you just go to the back of it. See? There's the add the 7, there's the minus 7. Add the 7, minus the 7. And then out of it all, there is the framework. So the framework will tell you what you need to do. Every number goes through this framework. Is there enough to add the beads? No, then do the 5. If not, then do the 10, right? And it's the same thing with addition and the subtraction. So you have the subtraction. If you have enough to subtract, then do it. If you don't, then can you minus the 5? If not, you can minus the 10, right? Yeah. I really like this one. This was a very encompassing I really do like it. And yeah, so you can bound it or you don't need to bound it, but it does take a little bit. But I appreciate that. Thank you so much, Comfy Bear. So, oh yeah. So, Simbayan. So right now, minus the 10, plus the 10, so we added the plus the 10. And again, it's the same process. We understand how to make a 10, right? After you make a 10, we have to find different ways of making the 10. And then this is the different combinations. And after that, we go into adding and subtracting the 9. And then every question is very specific to how to make a 9. So if I want to add the 3, how do I add the 10? How do I add the 9? So if I add 3, is there enough to add the 3? No. So what do? I know to add the 9 is plus the 10 minus the 1. So I'm going to plus the 10, I'm going to minus the 1. So my final answer is 12. So I go through step by step on how to use the numbers. And once you understand that, then we do into two-step. Oh no, after this. After adding in the 10, there's a minus 10, which is what I'm working on right now. But yeah, it seems like for your child, it seems like the book will take about 3 weeks, 3 to 4 weeks. I think that's a good that's a good time. If it takes about a month to go through one book. I didn't want it to be like huge, but I also didn't want to be overwhelming, if that makes sense. Because the big books that I see, it's overwhelming and it gets confusing. So I'm trying to be very specific and very focused. So then when you do know this, anytime you add and subtract, it doesn't matter. It doesn't matter when you get to the bigger numbers. Yeah. Yeah. Thank you, Sabayan. Yeah, let me know if you have any questions. I do have an online class, but it's videos. What it is, it's a membership, and it's just videos on going through all of the worksheets, and yeah, and then I offer yeah, and then you have my lives, so you can always ask questions through anytime. Anytime I'm live, you can always ask questions. You can even ask me questions, and I can do posts, but it takes time for me to post because I'm always on live. Yeah, yeah. Like I don't know if Laura's still here, but like yeah, Laura's bought a few things. Like bought a book, and her daughter was very excited for it. And it took her daughter 3 weeks to go through it. And I was trying to make it interactive and stuff. I've been so quiet. I've been on your side behind your phone. You're an amazing teacher. Oh, thank you. I'll buy more books for my granddaughter later. You guys are so awesome. Thank you so much. I appreciate that. I try to be focused. I try to be very specific to my teaching. And in the Abacus, which is really cool, there's an actual framework. I have a parent that's gone through, is going through my course right now, and her son is having problems with the mainstream math book just because it's just all over the place and it's very confusing. But if you follow this framework, if you follow this, not step by step, but if you follow the framework of Abacus, then everything else after that will be easy, if that makes sense. But yeah, thank you so much, Simbayan. I, user 397, let me know if you have any questions or if there's any typos or whatever, and I can accommodate. Let me see if I can accommodate either like a digital download or what have you. I've been trying to update as I see typos because obviously every question that you see here is something that I have to review and edit. And obviously through editing, I don't see all of it through the first or second pass. And so, I don't know, Simbayan, if you wanted to look at this. This is a abacus maze. This means that we're just focusing on two digit numbers. And so again, it's another maze, but we go through, and if you look at this maze, I don't know if you can see that. If you look at the maze, right, this is 48. So you just follow the thing. Is the bigger abacus available on your site or just on TikTok? It's available on my site. No, not yet. It's only right now. It's only available on my TikTok. I didn't put it up on my site yet. I've been more focused on TikTok because it just seems like it's easier to buy from TikTok. But if that's a problem, it would take a little bit for me to get there. I haven't been able to take the time to, but I should. No, you're right. I should put it on my site. I'm trying to populate my site as much as possible, but I get it's just there's a lot of moving parts. I didn't realize how many moving parts there were, but there's a lot of moving parts. But I appreciate that. Yeah, I'm trying to make it what I'm trying to make it. I'm trying to make it the same everywhere, like hands down, but it's just not working. So how many books altogether? That's a great discount for all of them. I don't know yet. I'm still in the process of making the minus tens, and I haven't finished the series, and I haven't been able to figure that one out. Not just yet. So right now that's individual. Oh, and I am available if you're looking for. I am also available on here. Hi, my name is Lynette. I've been teaching Abacus for 20 years. And right now, that's where the books come from. The books come from here. And so you can either buy it there or you can buy it from the shop. It's up to you. You can either buy it here or from the TikTok shop. I haven't. On my website right now is a digital download. I have yet to put up the physical book. And I haven't thought about I haven't thought about a bundle yet. I'm still in the process of making everything. Yeah, because I think my final step would be finishing up what we call a two-step equation. So that's when we start Tetrising our way through, and it'll be a little more complicated. But you have all of the information. It's just another step. I don't call it mixed formula. I call it, what do I call it? I call it two-step. But in Abacus world, it's called a mixed formula. It's called mixed. And I'm like, that's so generic. It's such a generic term. I don't like it. So I don't call it mixed formula. But if you ever did do research on it, there are people that teach Abacus. Obviously, they don't teach it like the way I do. Because I'm trying to make it more mainstream. That's what I'm trying to do. I'm trying to mainstream Abacus, whereas the other Abacus teachers that's on TikTok or everywhere else, they talk about big friends, small friends, little friends, whatever. But I'm talking about how to make a 5 and how to make a 10. Because why? Because mainstream math, right? Mainstream school talks about how to make a 5 and how to make a 10. So that's what I bank on. And then what I'm trying to do is I'm trying to utilize the words, isolate the variable. I only say this to adults, right? I'm not going to say this to young kids. They're not going to understand what isolating the variable is. But because I'm teaching you guys, I want you guys to understand what isolating the variable is, like what we're trying to do here. So that's why we have this. That's why I have this specific erasable workbook, because I wanted to make sure that I get the understanding. Like we have this thing called commutative property. This commutative property is, being able to take the formula and switching it. It is not an exact definition, because in the mainstream the Eurocentric math, they talk about addition states, but this is not an addition state. This is a minus state, right? This is a subtraction state. So the difference between, we have words, but in Abacus world we never use this kind of words, if that makes sense. We never use the word commutative property. We also don't use the word distributive property, but that's what we do when we do multiplication. Yeah. All right. So, does anybody else have any questions? If not, I appreciate everybody here. Thank you guys so much for joining. Wow, 20 people. But yeah, if there's no other questions, I am going to end the live. I've been on for a little bit, and it's time to head out. Yeah? So thank you again for everybody joining. Thank you again for commenting and asking questions. And I do enjoy any kind of conversations. Yeah, see you tomorrow. See you tomorrow. Thank you so much. All right. Have a good day, everybody. And I'll see you guys all in my next live. Bye. Bye. See you later, thing. Bye, user 397. See you later, CompuBear. See you later, Reeves. Been so quiet. I don't know if you're still there. All right.